All right, today we're going to be working on 1.2, section 1.2, so everything that you get here, or if you're filing at home, section 1.2, and this is solving multi-step equations. Multi-step equations are just going to be more than one-step equations. Could be 2, could be 3, could be 5, could be 10. Who knows? Multi-step, we just have multiple steps that we are going to have to jump through in order to get that variable by itself and solve for it. Most important thing that you guys can do starting out with solving multi-step equations, you always want to simplify each side. So what's on one side of the equal sign, what's on the other, each side of the equation. We're not always going to have to do it, so that's if necessary. After we simplify both sides, then you're going to use your inverse operations to isolate that variable and get it by itself and solve for it. Very important key concept though. Simplify both sides of the equations before you get started. That will make life much easier for you. There's nothing really we need to explain. I just really want to show you a bunch of examples on what you're going to run into on your homework. So here I have 2.5 or 2.5x, subtract 13 is equal to 2. If I gave you this equation and I said, let's substitute a number in for x. Let's substitute 1 in for x and see what we get. If we would substitute 1 in for x, you would follow order of operations. Say, well, x is being multiplied by 2.5 and then subtracting by 13. When you're solving multi-steps, if you're having trouble figuring out what to do first, always ask yourself, what is happening to my x? Following order of operations. Well, if I look at x again, it's multiplied by 2.5 and subtracted by 13. When doing this, we need to reverse this. We need to reverse it to get the x by itself. We're using reverse order of operations. So I'm going to write this down on the first two probably, but then I'm not going to write it down after that. Here's what's happening to x. X is being multiplied, I'll use a little dot for multiplication, by 2.5, and it's being subtracted by 13, meaning if I plugged a number in for x, I would multiply it by 2.5, then I would subtract by 13. In order to solve for x, we need to reverse that using your inverse operations. So if I subtract 13, my first step would be to add 13. If I multiply by 2.5, my inverse operation is divide by 2.5. Those are the steps right there that I need to follow to solve this equation. Most of us aren't going to have to go through with this, but sometimes it helps just starting out. So my first step would be to add 13. And what I do to one side of the equation, I must do to the other. My 2.5x stays. Negative 13 plus 13 is 0. That's exactly what I'm looking for. 2 plus 13 gives me 15. Next step would be to divide by 2.5. What I do to one side, I must do to the other. If I divide by 2.5, I then get x is equal to 6. And I can go ahead and check this. 2.5 times 6, well, 2 times 6 is 12. half of 6 is 3, so 12 plus 3 is 15. If I subtract 13 away, that indeed gives me 2, and I will box that in. Next example. Negative 12 is equal to 9x, subtract 6x, plus 15. And again, if I go back up to the first thing I said, simplify each side of the equation if necessary. Simplify means we are going to combine like terms. We are going to make this easier to solve by combining like terms. Remember, combining like terms, I can only combine them when they're on the same side of the equal sign. If they go to other sides of the equal sign, which we'll get into in a couple days, we have to use inverse operations. But for today, in the next couple of days, we're just going to look to see if we can simplify first. I can combine my 9x subtract 6x. Negative 12 is equal to 9x minus 6x, leaves me with 3x plus 15. Now, much easier to work with. I just have a simple two-step equation. I'm going to write out my steps again of what was happening to x. If I plugged in a number for x, the first thing is multiply by 3, and then I add 15. Remember, in order to solve this, you need to reverse that. First step is going to be to subtract 15 and then divide by 3, because I'm going to want to use my inverse operations to do that. First step, subtract 15 from both sides. Negative 12 subtract 15 gives me a negative 27 is equal to 3x. That's gone. That's what I'm looking for. My next step, x is being multiplied by 3. In order to undo multiplication, I divide both sides by 3. Negative divided by a positive. My answer is definitely going to be negative. And 27 divided by 3 gives me 9, negative 9. And I can go ahead and plug that back in and check it. I could check it here if I'm confident in my steps. Usually when we're checking equations, you're always going to want to go back to the original equation in case you made a mistake here in your combining of like terms. On this one, I'm pretty confident 9x minus 6x is 3x. Negative 27 plus 15 indeed gives me negative 12. I'm good with that answer. I'm going to box it in. Here are two examples. Negative 2n plus 3 is equal to 9. Negative 2x subtract 10x plus 12 is equal to 18. I'm going to give you just a couple of, pause the video there, take yourself some time, do these problems out, see if you get them right, and I'll have the solutions here for you in a second. N is being multiplied by negative 2, added by 3. I need to reverse these, so I am going to subtract 3 first. That leaves me with negative 2n, that's 0, is equal to 6. 9 minus 3 is 6. N is being multiplied by negative 2. I divide by negative 2, and then is equal to negative 3. If I plug negative 3 back in, negative 2 times negative 3 is positive 6. 6 plus 3 equals 9. I know that's right. I'm going to box it in. On this example over here, Look to see if we can combine some like terms. I certainly can combine negative 2x and negative 10x. Negative 2x subtract 10x gives me a negative 12x plus 12 is equal to 18. X is being multiplied by negative 12, added by 12. I need to reverse this. Got to isolate that variable, get it by itself. I will subtract 12 from both sides. My negative 12x comes down. That's 0, that's what I'm looking for. 18 subtract 12 is 6. I would divide both sides by negative 12. I have a positive divided by a negative. I know my answer is going to be negative, and this is 6/12. That will get you some points. We are always going to simplify this. This fraction needs to be reduced. X then would equal negative 1/2. Reduce your fractions for full points. I am going to flip my paper over, continue on with some more examples. Next example, I have 2 times the quantity 1 subtract x plus 3 is equal to negative 8. Here I've got some parentheses. We got to go back to 7th grade here. Remember, if I have a number outside the front of a quantity that is within parentheses, I need to distribute. Use the distributive property. And remember, distribute means multiply. I have to multiply 2 times 1 and then 2 times negative x. 2 times 1 gives me 2. 2 times negative x gives me negative 2x. Plus 3 is equal to negative 8. Got to distribute, got to multiply. Here, I've got some like terms. Will make my life much easier. Save me a step and some work if I combine these like terms first. So I have negative 2x, then I have a positive 2 plus 3 gives me 5. That is equal to negative 8. Now, x is being multiplied by negative 2, added by 5. Simple two-stepper here. So I need to subtract 5 from both sides, leaving me with negative 2x is equal to negative 13. I then would divide both sides by negative 2 to undo that multiplication. X then would equal negative divided by a negative, positive 13/2. Or, since that decimal terminates and ends, I could write it as a decimal as 6.5. I would get in the habit, though, I like this answer a lot better than this answer. Yes, I will absolutely take that one, and it's going to make it easier when you plug it back in with your calculator to check it, but we are going to get in the habit of leaving our answers in improper fraction form, meaning my numerator is bigger than my denominator. I don't want to see this as 6 1/2 as a fraction either. I would rather see this or this. We don't need to make it mixed. By mixed, I mean writing it as 6 1/2. Just makes it more difficult when I go to plug it back in. This answer is best, second best. Not going to mark it wrong, but not what I'm looking for. Next example. 3 times x plus 1 plus 6 is equal to negative 9. Go ahead and pause the video, get that down, give it a try, and then see if you get what I get. Here we go. This one I'm just going to attack a little bit different to show you that there is no exact way to do these. I could absolutely distribute first this 3 to this x plus 1, and then I could combine. I can see that I'm going to have to combine some like terms, and then I could solve for x. Here I distributed first and then combine like terms. Here I just want to show you, because this is multiplication here, it doesn't really matter if I subtract this 6 first. If I subtract 6 first, I'm still going to be left with 3 times the quantity x plus 1. That's gone now, is equal to negative 15. I could also now just distribute right back up here. 3 times x, 3x. 3 times a positive 1 plus 3 is equal to negative 15. X is being multiplied by 3, added by 3. I need to reverse that by subtracting 3 from both sides. That's gone. Negative 15, subtract 3. Negative 18. I would then divide both sides by 3. X is equal to negative 6. And I can certainly plug that back in here to check it. Shouldn't be that difficult to check. Negative 6 plus 1 is negative 5. 3 times a negative 5, negative 15. Negative 15 plus 6 indeed gives me negative 9. And I'm going to box that in because I'm confident it's correct. I want to take you back to this step right here, though, because here is another way we can do this problem. Since this is multiplication right here, I can think of this whole quantity within these parentheses as a variable. If I gave you 3 times y is equal to negative 15, I'm sure all of you could tell me that I would divide both sides by 3, and that would leave me with negative 5. I can use that same concept right here at this step. Because this is multiplication here, I can undo this multiplication by division. And since I know that negative 15 is divisible by 3, it might be a little easier and a little cleaner if at first I divide both sides by 3. Those would then divide into each other, leaving me with x plus 1 is equal to negative 5. Then I just have my simple one step here. X is equal to negative 6. Which is correct? Both are correct. When would I use this little trick here? When what it's equal to is divisible by what that quantity is being multiplied by. It's really not going to do me much good if this was, say, an 11, a negative 11. If I divide by 3, now I'm working with fractions. Then you're working with fractions in multiple steps. If this is evenly divisible, I have no fractions. Even if this were to come out as a fraction, you're just going to have multiple steps involving fractions instead of just simplifying at the end. Either way is correct. I will go back and forth doing both ways. Last example. Negative 4 times a quantity 2m plus 5, subtract 3m is equal to 35. Now when I look at this one right here, I've got this negative 3m here. It's going to do me no good to move my variable to the other side. I've already got my variables on both sides of the equation. I really don't want to divide by negative 4 because remember, if I divide by negative 4, I divide this by negative 4, this by negative 4, and this by negative 4. That goes back to the equivalent equations that we talked about. You can divide and multiply everything by the same thing, but you have to do every term in your equation, and that becomes messy. We're not going to do that. We are just going to distribute negative 4 times 2m, negative 8m. Negative 4 times a positive 5, negative 20. I'm left with my negative 3m is equal to 35. I now have some like terms I'm going to combine here. Negative 8 subtract 3. Negative 8m subtract 3m, negative 11m subtract 20 is equal to 35. M is being multiplied by negative 11, subtracted by 20. I need to reverse those by adding 20 to both sides and then dividing by negative 11. So first I will add that 20. Negative 11, that goes away. 35 plus 20 gives me 55. I would divide both sides by negative 11. M then would equal, I have a positive divided by a negative. My product, or my quotient, will be negative. 55 divided by 11 gives me a negative 5. And I can go and plug that back in and check it. Negative 5 times 2 would be negative 10. Negative 10 plus 5, negative 5 would be a positive 20. So this would be 20. Negative times a negative, negative 3 times negative 5 would make that a positive 15. 20 plus 15 indeed gives me 35. That checks, and I am boxing that answer in. That is solving multi-step equations. What we want to wrap this up with is remember to look at the problem, see if you can simplify on one or both sides of the equation to start, and start thinking before you start plugging numbers in. How is this going to look? I'm going to have to distribute. I'm going to have to combine some like terms. Just start thinking it through before you blindly start just going through to solve the equation. Think about them first, look at it, be organized, get your answers, check your answers. Good luck on your homework.